Hey, this is Miss Oliva, and I'm going to go through solving exponential and logarithmic equations, which is from 3.5. So here is where we're going to put a lot of the rules and properties that we've been learning together in order to solve equations. So one of the trickier parts of this is that each equation is going to be different, and so you'll have to be able to identify kind of what method would be helpful to solve. So the first thing that you should try to do is if there's a way to make these two bases the same, then this problem isn't so bad. Because if we had something like 3 to the x equaling 3 to the 5th, x has to be 5, right? So basically, if we can make the bases the same, then we can ignore them and just focus on the exponents. So if you can do that, that's what you always want to do first. So I can rewrite this because 256 is 4 to the 4th power. So now we can basically ignore the bases and set 2w minus 4 equal to 4 and solve. So I'm going to add 4 and divide by 2. When you're solving this kind of equation, you can check your exponent, but you don't really have to. When we get into the log problems, we're going to have to check our answers because they might not work. So I'm not going to check that one and just assume I got it right. So for this one, again, if I can rewrite these to have the same base, I will be happier. So 36 is 6 squared. So I can rewrite this, but be careful because it's an since it's a fraction, it's not going to just be 6 to the 2nd power. It would be 6 to the negative 2nd power. So then I'm just going to put the exponent that was already there like that. So the 1 over 36 became 6 to the negative 2nd. But now that I've written it where the 6's are the same, I can set the exponents equal to each other and solve from there. So I'm going to distribute my -2 and solve. So I'm going to add the 2y over here, add the 8, and divide by 4. Again, since this was an exponent question and not a log question, I don't really have to check this. But if it was a test, I would definitely recommend checking because it's an easy way to find out if you've made a mistake, and then you can go back and try to find your mistake. Okay, here's finally one where we don't have a choice. There's no way I can rewrite 41 as 7 to the something. So we're kind of stuck at this point. But if you remember, if you ever have log base of a number to the same number, then it all wipes out. So I can take log base 7 of this side as long as I take log base 7 of that side. And it seems like that's made this a much more complicated problem, but it hasn't because like we said, we know that that all wipes out now. And so this is my final answer. Even though that doesn't look nice, if t is by itself, I'm done. So they're going to start asking you for 2 different types of answers. They're going to ask you for the exact answer, which would be this. And they're going to ask you for the approximate answer, which means what do you get when you put this in the calculator? Because you're going to have to round, so that's not your exact answer anymore. So remember, something like this, we can use the change of base formula for. So it becomes log 41 divided by log 7. And now I can put that in my calculator and round it to whatever they want me to round to. I don't remember, so I'm just going to guess that it was 4 decimal places, but make sure you read what they want you to round to. So in this case, that would be 9084, 1.9084. So exact answer is once you get that letter by itself, even if it's not a pretty answer. But anytime you have to round, then you're giving the approximate answer. Okay. So when I look at this, I see that again, I'm trying to solve for something that's in an exponent. So since that is part of this 10, my first step is going to be to just get this by itself. So anything extra, I'm going to move to the other side first. So I'm going to subtract the 8,800, which gives me, I did this one somewhere already. Okay, which gives me this. And now I'm going to focus on bringing this down, which means I'm going to need to do log base 10, which is just log of both sides. So I'm doing log base 10 because again, that'll let me wipe that stuff out and leave me with just the exponent. So now I'm here. I still need to get this by itself. So I'm going to subtract 2 and then divide by 9. So it is not pretty, but this is your exact answer because if I go any further, I'm going to get decimals that I need to round. So that is the exact answer. Put it in your calculator and get the approximate. So I'm going to assume that you guys can do that, okay? So looking at the next one, again, I see that we're trying to solve for something in an exponent. So I'm going to get this by itself first, which means divide this time by what was outside. And that gives me 0.125. And so now this time, the base that I would like to wipe out is an E. So remember, instead of doing log base E, that is what ln is. So when you're trying to get rid of an E, you do ln. But if you do it on one side, you have to do it on the other side. So I have ln of this equals, this comes down now. And so all I have to do at the end is divide by that negative 0.5. And again, not pretty, but that is my exact answer. And I'd have to put it in the calculator and round to get my approximate answer. Okay. In this case, we have two completely different bases, and they both have exponents with x's. So we could do something like log base 7 to at least wipe this one out, but it's a little easier to deal with if we don't have quite so many logs all over the place. So when we have two completely different with x's in both exponents, it's a little easier basically to write if we do ln of both sides, because at least that will allow us, even though nothing will wipe out, to bring these exponents out front. So this one gets a little tricky because we're going to bring this out front times ln 7 and bring this out front times ln 6. And that looks weird, but remember that this and this are just numbers. So if we had a number outside of a parenthesis, wouldn't we normally distribute it? So that's what we're going to do with these ln's, is we're going to distribute them inside these parentheses so that then our x's aren't stuck inside the parentheses. So that's going to give me 3 ln 7 minus 5x ln 7 equals 3x ln 6 minus 2 ln 6. So it's a lot. And here's one of my x's and here's the other. So we did one of these a couple sections ago where if you're trying to solve for a letter and there's two of them in your problem and you can't kind of combine them, then at least get them both on the same side of the equation so that you can factor out that variable. So I'm going to get the two things with x's on one side. So I'm going to keep the negative 5x ln 7. I'm going to move this over by subtracting it. And then on the other side, I'm keeping this where it's at, but I'm moving this one over by subtracting. So it's just moving what you need to move so that both of the terms with x's are on one side and both of the numbers that have no x's are on the other side. And so now I can factor it out and it'll finally be by itself. So now I went from two separate x's to just one nice x by itself that's being multiplied by all of this. So I can get rid of all of this in one step by dividing by the whole thing. This is definitely one of the more complicated types. So definitely not pretty, but this is my exact answer. X, is this all wiped out? X equals all of this, and you'll have to carefully put that in your calculator to get the approximate answer. Okay, what happens when you see something like this? Well, first remember that x times x equals x to the second, right? So when you're multiplying, you really add those exponents. So when we see a 2r here and an r here and then nothing here, this is similar to a problem like this. Because that 2 means we basically have something that got squared, it by itself, and a constant. Well, something squared, it by itself, and a constant. So basically, we can factor this. So we can factor this the same way we would factor this. So if you want to do it with x's first because you're more comfortable, that's fine. And then you can go put it into what's happening here. So for negative 42, I need two numbers that add up to negative 11 that multiply to negative 42. And I think 3 and 14 work. So we would want a negative 14 and a positive 3. So applying that over here, the only difference is instead of x and x, to get to this e to the 2r, we would need e to the r and e to the r. Because remember, if I multiplied them, I would really add the r's, which would give me 2r. So I just need to put my same numbers in there. And now I can start solving. So I'm going to set each one separately equal to 0 and solve. So here I subtract 3. If I take my ln of both sides, which is what I want to do to get rid of that e, I have an issue. This wipes out and I get r, but on the other side I have ln of negative 3. And remember that we cannot take a log, and ln is a log of a negative number. So when you get to that part, if you're sure you haven't made a mistake, you can just stop and say, this one, there's no solution for this one. But now let's see if this one works. Adding 14 and then doing that same ln to get rid of the e, our answer is ln 14. And depending on if they want approximate or exact, this would be the exact. So we could have had two different answers, but since this one didn't work, we ended up with only one answer. Okay, something like number 8. If you have the same exact log and base on both sides of the problem, this is similar to when we had the same base, that we could basically just ignore those and focus on the exponents. Same thing. If log base 2 of this should equal log base 2 of that, then these two things have to be the same. So we can just ignore the logs for a second and set these equal and solve. But this is one where we need to be careful and check our answers, because we might get an answer that works for this, but putting it back into the log, if it makes either of these 0 or negative, we know we can't do that. So we got to check our answers and make sure that doesn't happen. So I'm going to add the t over to here to keep it positive. I'm going to subtract 23, which gives me a negative 10, and I'm going to divide by 2. So I got a negative number, but that does not automatically mean it's wrong because t can be negative. It's just that this whole thing cannot be negative. So check it. If we plugged in negative 5, we would get 13 minus negative 5, which really means 13 plus 5, which is 18. If we plugged it in over here, negative 5 plus 23, same thing. So even though t is negative, it's totally fine because when we plugged it in, it did not give us a negative or a 0 answer. So you just have to be careful when you're doing a log problem to check your answer to make sure it's okay. So that's when you have one log on each side and they match. When you only have one log in the whole problem, you're going to treat this similar to when we only had one e or 1/7 to a power, and we're going to get the log by itself and then figure out what to do. So I need to move the 3 and the 5. Make sure you move the 5 first. Now I can divide by 3. Okay, once you get to here, don't forget that we have a method of going from logs to exponential. Sometimes in log form, it's easy to solve, and sometimes in exponential, it's easy to solve. So if you get to the point where you're kind of stuck in one form, switch to the other form. So wouldn't that mean 3 to the 5th power equals 5w plus 3? This looks like something I can solve because 3 to the 5th is 243. And I can just solve from here. Subtract 3 and divide by 5. Make sure if you plugged that number in, it wouldn't do anything bad here. We don't want 0 or negative, but it seems fine. So again, when there's only one log in the problem, you're usually going to want to get it by itself. And then if you're stuck, change it to exponential form. Okay. So I'm going a little fast because I wanted to do a lot of examples so you can see all the different types. So this is exactly like what we just had. We just had less work to do. We have a log by itself and we're stuck. So I'm going to rewrite it. Remember, if there's no base, it's really a 10. So this would be 10 to the 4.1 equals q plus 1. This would be your final exact answer, or put it in the calculator and round it. Okay, these are the most complicated because we have more than one log, but they don't equal each other. So remember earlier we had a case where we had like a log 6 and a log 6, but that's all we had, so we could ignore them. This one becomes more complicated when it has that extra part right there. So instead of just ignoring them, because that wouldn't really work out fair, I'm going to get both logs on one side and use the properties we learned before to put it together. So remember a section or two ago, if we had more than one log being added or subtracted, we could combine them with multiplication or division. So that's what I'm going to do. I'm going to put these two logs together and say they equal log base 6 of the one times the other. And now that I'm down to one log, I'm going to change it to exponential form. So 6 to the 2nd power equals all of this, which really means 36 equals this. Don't forget, when you have something squared and itself, and you have a number, not a 0, you want to move everything on one side so you can try to factor. So I can factor this with y minus 36 and y plus 1. So that means right now I have two answers, which are 36 and -1. But I need to check them. 36 would be fine here and would be fine here. -1 would not be fine here because I'd be taking the log of a negative. So I don't have to check any further. If it doesn't work on one side, it won't work on the whole thing. So my answer is just 36. So this one is similar, there's just more. So I'm going to try to make this have just one ln on both sides. So I'm going to leave what's on the right, and I'm just going to try to combine these. So they can squeeze together and become ln of x times x minus 7. Now I do have one ln on each side with nothing extra. So now I can ignore it for now. I'm going to go ahead and distribute this while I'm at it. I'm solving and I have an x squared and an x, so I'm going to get everything on one side and see what I can do from there. So now we need to factor. So -5 and -11 would multiply to 55, but would add up to -16. So those are my two factors, which means if I set it equal to 0 and solved, I would get 5 and 11. Well, let's make sure they're work. 5 would be fine here, would not be fine here, because that would give me -2. 11 would be fine here, would be fine here, because 11 minus 7 is positive, and would be fine here. That would be 99 minus 55. So 11 is our one answer. Okay, finally the two-word problems. We've done problems like this before, but we've done them where we needed to find the A or we needed to find the P. But now that we know all these log rules, we can see how they're going to help us find out if it's the rate or the time that we're missing. So it says if 13,000 is invested in an account, so that's the P, earning 5.5% interest, so that's the R, compounded continuously, so that means to use the formula with the E, determine how long it will take the money to triple. So I know that I'm starting with 13,000. I know I'm using the formula that's E to the RT. My rate is 5.5%, but be careful that you change it to a decimal, not a percent. So that would be 0.055. And we do not know T, and that's what we're trying to find. If I also put an A here, then I'm stuck because we can't solve if we have an A and a T. We need to have only one variable. So the key to what to put over here is the fact that they're asking how long it will take for the money to triple. Well, if we know we're starting with 13,000, then it's going to triple when it gets to 39,000. So that was the trick there, that they didn't really tell us the ending amount, but they told us by saying it needed to triple. So now to solve this, I would divide by 13,000 first. That gives us 3 equals E to all this. To get rid of the E, we do our ln. So ln 3 equals this. Oops, I'm missing a 0 there. 0.055t. And so we divide to find t. And it says round up to the nearest year. So ln 3 divided by 0.055 is 19.9747. So rounding to the nearest year would mean 20. So it takes about 20 years for our money to triple. And then finally, 14 is a word problem talking about coffee. It says that if 1 cup of coffee has 80 milligrams of coffee, then here would be the equation to figure out how many milligrams of caffeine are left after so many hours. So we're assuming that coffee starts with 80 milligrams of caffeine, and we're seeing how many would be left after however many hours. So the first question is, how long will it take for the amount of caffeine to drop below 60, round to 1 decimal? So what they're saying is they want the caffeine to be 60. So if we plug in 60, we're going to try to get the thing that has the exponent by itself. So we're going to divide by 80 first. 60 divided by 80, 0.75. I didn't really give myself much room for this. So now we're here. If I do ln of both sides, I can at least bring this down. So I get ln 0.75 equals negative t over 6 times ln 2. So I'm going to divide by the ln, and that leaves me with just the negative t over 6. So my last step to get rid of the negative and the 6 is just to multiply by negative 6. So kind of ran out of room, so work this out and see if that makes sense. But this would be my final answer, negative 6 ln 0.75 divided by ln 2, and I want you to round to 1 decimal. So I guess I'll do that if you want to check to see if you're doing it correctly in the calculator. I get 2.49. So if they want me to round to 1 decimal, it'd be 2.5. So it would take about 2.5 hours for the caffeine in my system to drop down below 60 milligrams. And then finally, B, Laura has trouble sleeping if she has more than 20 milligrams of caffeine in her bloodstream. How many hours before going to bed should she stop drinking coffee? So it's basically asking how long will it take for the caffeine in her system to get to 20. So instead of 60, we're going to do the exact same thing, but plugging in 20. So exact same work I did before. You'll divide by the 80, take ln of both sides so that you can bring this down, and then do the same thing I did here. Divide by the ln, and then multiply by negative 6 to get rid of that negative and the 6. So try this one and let me know if you have any questions when you try your homework. If anything needs more explanation, feel free to text me or email me.